Welcome in this webinar. My name is Tom Vorstelmans. I'm the product manager of our data integration solution, Solventure Connector. And today I will introduce you into that world. I will explain you what our product does and why we did build it and how it's linked to our integration approach. And I will end with a demo of our product to show you how the product looks like and what it actually does. I first wanted to take a step back. Yeah, so when Solventure was founded, I think 2005. The focus was fully on optimizing supply chain processes and implementation of planning solutions to support those processes. Solventure is the implementation partner of Archiva, which is a advanced planning solution in Europe. And of course, we need a lot of data in order to set up planning. So in the beginning, Solventure started doing flat file integration. And of course, that works fine, but it also has some limitations, of which we learned a lot. And one important one is that you need to define all your data requirements at the start of a project. And you need to tell, okay, what content of each file, which columns do we need, what is the content of each column that we need, and that's not easy to do it from the start, especially because you cannot see which data is available and where it is, how it is at this customer setup. There's no possibility to explore your data upfront. So not possible to assess the data quality until you receive the first file. So you first need to wait a while often, and this places also a dependency of an IT expert to find that data in the system, then to automate that and to create the necessary files. File-based integration also holds some technical risks, because when you export files, there is no check on, for example, duplicates, or all the data in your file is converted to text. So there's always a risk on conversion issues of dates or decimals. And that got us thinking. So in 2018, Solventure started investing more and more in data integration, and a dedicated data integration team was founded. We also started the development of our connector product, and that's where I will talk, of course, a lot more about today. Another thing that got us thinking was ERP systems. So customers that implement planning systems, of course, many of them have a centralized ERP system, one or multiple, depending on the size and the context. And ERP systems, they need to support a lot of business processes. So they're typically very large IT systems, and that makes that they also have very large and complex data models behind the scene. For example, SAP has more than 100,000 tables. I believe that the newest version, S/4HANA, even has more than 800,000 tables in the database. So that makes it very complex to find the right data. And because ERP systems, they need to be configurable and flexible, they also often implement complex data models, and that makes it also hard to link all the data together in a correct way. And the last thing is that the tables in an ERP system have often meaningless names. I think SAP is a champion in that. I think all their tables and fields have a 4-letter abbreviation. And I think if you know a little bit German, then you can understand sometimes where it comes from, but it stays difficult. At the other hand, ERP systems are standardized. A lot of companies implement them, and the same data objects are stored in the same data structures, which is very interesting from a planning perspective, because we often need the same data objects. And also the technical metadata about the tables is pretty easy to extract from an ERP system or another system like a database. You can extract the table names, the data types, and even the descriptions of the fields pretty easily. So that also got us thinking, and that was the starting point for our product. Here you see an overview of some of the subtables we need in almost every setup. And you see it's not very readable, but we said, okay, let's capture that metadata and store it in the repository. So by doing that, we were thinking, okay, this is not the language we talk often. So we said, okay, let's group them together in functional groups, because we talk about bill of materials, we talk about sales orders, materials. And we said, okay, let's link both worlds together and also capture that data into our repository. We even went one step further and we said, okay, let's organize it a little bit and let's also add some readable names to it. So we know directly from the start which data is stored in which tables. So at that point, we had a template repository. We were building it up based on our experiences. And then we said, okay, our templates, from our experience, they cover around 80% of the data requirements of a project. But of course, you need to cover 100%. So we said, okay, let's build a customer repository for each customer, and where we can import our templates, and then we can start enhancing them. So that's what we did with our product, and we took it one step further, and we said, okay, based on that metadata we have now, we can generate deployable code. There we make the decision to go for the Microsoft SQL Server ecosystem, because Archiva behind the scenes also has SQL Server as backbone. So for us, was a logical step, and we said, okay, based on that metadata, we can generate all the SQL to create our database, and we can create also integration packages, Microsoft SQL Server integration services packages that can then extract, transform, or load all the data between the ERP system and our planning solutions. And that makes it very powerful because doing this flow, we can start from our template, import it in our repository, we can generate code and immediately extract the relevant data. And that makes it possible to analyze your data in a very early stage of the project to identify potential quality issues, for example, but also to talk with business about the data requirements and enhance them in an iterative way. So it makes it much faster to come to a final set of data you need for setting up the planning solution. And in the end, those packages can then be deployed on the different environments. So typically we have 3 environments: a development, testing, and production environment. And those packages are then generic, and we can deploy them on the different environments without problem. So how does that links to our integration approach? Here you see our integration architecture overview. And on the right, you see the planning layer. And an advanced planning system like Archiva, for example, is typically organized in modules. And often customers start with demand planning, and later they also do supply planning, where you have different types and different levels of aggregation, from high level to planning on production line level, or focusing more on financial planning. And typically those modules, they have different data needs, but also a lot of the data overlaps. So like each module needs data about materials, but not all modules need the same data. On the left, you see different data sources. ERP systems are an important one, but it can also be that we need to extract data from data warehouse, for example, or from REST APIs or data endpoints. and in some cases still, of course, flat files, but we try to avoid that. In between, we place our integration layer, where we have a centralized database. We call that the data mart, where we collect all that data and make it available in a data model in business language, always also often referred to as the canonical data model. And in this data mart, we then consolidate data from multiple sources, or sometimes also multiple ERP instances. So this, from the planning perspective, there is only one source, which is the data mart. And this allows to make abstraction of all the technology. So it doesn't matter anymore if the data comes from a SAP ECC system or a SAP S/4HANA system. That is hidden because we add that intermediate layer. Also on technical level, it offers opportunities because we can apply delta loading to extract only change data, or to load data through a moving window instead of extracting the full history each day. Inside our data mart, we have 3 layers. The first one is the ingest layer. That's where we capture the raw data, and that's where our templates come into play. Here we can very fast extract the relevant data with our templates and start analyzing it. The next step is then to model, create a data model and consolidate the data model, and there we translate everything into business language. And then the last area, it's a publishing area. There we make data available for consumption by the planning layer. And so there we typically make distinction between each of the modules, so we know which module is consuming which data of the data store layer. Here you see an example, and I hope it looks familiar. Here you see a link to our templates. This is the material template, our sales order template, customer template. So in the ingest area, we capture all the raw data. In the data store area, we then transform and filter all that data. We use business language that is also used inside the planning layer. We apply the relevant filters. We combine and simplify the data model. And we combine different source tables into one target table. And then we make it available for the different modules of the planning solution. So on technical level, it works like this. So our tool generates SES packages, and we make use of the RFC protocol of SAP to extract the data. So our package does a call to a function module inside SAP to, for example, request data from a subtable. SAP returns the data in buckets, for example, of 10,000 rows, and then we load that into our ingest area. Inside our data mart, we then go to the next layer in the data store, where we transform and filter everything, and then make it available to for the planning tool. Here, for example, Archiva as example. Also, uploading is often necessary. For example, the output of a planning tool can be forecast or planned orders that often needs to flow back to the ERP system. So there, the planning tool is the source. So we extract the data, we transform it to the format that the target expects. And then with our SES packages, we upload it back into SAP. And there we typically leverage the BAPIs of SAP in case of a subcontext. For example, to upload forecast, there is a BAPI to upload independent requirements, which we use then to create the forecast into the subsystem. Okay. So that brings me to the demo of our product. So here you see the Solventure connector in action. And you see it typically takes 5 steps to go from an empty configuration to a scenario where you can deploy the solution and start extracting data. It all starts with configuring your connections. So a connection is actually a set of parameters to connect to an IT system. So for example, if we want to connect to SAP, you need to define the parameters for each environment, how to connect with which user, which is a server name, and some technical properties. So that's a one-time setup that needs to be done to be able to connect to the system. The second step is then to import templates. So there is a template repository. Currently, our tool is focused on SAP templates. And there we organized everything according the business concepts. And below each of the business concept, we have then a list of SAP tables that are relevant in that context. So those are the relevant tables. So for planned orders, you can explore what is necessary. It is then possible to implement a template, which means that you create actually a predefined pipeline. So here you see already 3 examples where I already implemented one of the templates. And a pipeline is actually a step of a number of processing steps that can run in parallel, but that can also have dependencies in between. So here you see a pipeline of 4 tasks, 3 extractions of 3 tables, and then a task to transform the data into the format that we need. So for example, if I would then say, okay, we also need customer data in this case, we can easily say, okay, let's implement that template. And you see it was successful. So now we have a customer pipeline available, and all this data, metadata, is stored behind the scenes. And now it is possible to actually build this. And by building this, our tool will generate all the integration packages to do it. But it's also possible to enhance now, start enhancing the data from the templates, or to add extra steps. For example, we can say, okay, I want to add a task. And say, okay, we want to load that data into a centralized customer table, and we also want to create some dependencies. So let's say we first want to do all the extractions, and as last step we do then a transformation. And so here you see now transformation step added that is dependent on all these extractions. And so in that way, it is possible to start implementing our templates, and then in the end we can click on the build button, and now the tool is generating SES packages behind the scenes, and then that is so here you see the build was successful, and everything is available in a zip file that we can now install on our environment. So to give you an idea on how that looks like. So this is an example of such a build output. And so it's, yeah, of course, this is a technical output, a set of scripts to create the database, and a set of SES packages to actually extract and run all the flows. And here you see also an installer that can be used to install all these objects with one click in the right order, because that's also important that the objects are created in the correct order. And here you see an example of a visual output. So this is actually something I generated. That's the BOM template I just showed you in the tool. This is the end result, where you see a main package and one package for each step. And the main package orchestrates the dependencies between the flows. And so in this case, we can start extracting data, and then all the data ends up in our data mart database. That is what's currently happening. So data is being extracted, and we have a successful run. So in the database, we see now, okay, everything was executed successfully, and we have now the information available. So here you see immediately all the data that is available in this subsystem. And as I explained, we added immediately all the readable names of the fields, so we can easily also understand what is this, what is the content of this field. And then we can start this to analyze the data, but also then to build up our canonical data model to load that model. That's what I wanted to show you today. Questions from the audience? So, as I said, when I introduced the file-based integration, it's very important to start analyzing the data in an early stage of a project. So we try to answer that by speeding up the process of getting access to the data. So I think that's a very critical one. But then, of course, also taking the time to analyze it and to make sure that actions are defined in an early stage of the project, and not just when a project goes live. That's too late. It needs to be already in an early phase of the project that you need to validate, is everything okay? Is everything filled in that needs to be filled in? And not at the moment of a go live. And that's our attempt with our templates to make sure that we already extract 80% of the data requirements very quickly, so we can start working on that from the start, and then work on it in an iterative way, and eventually, if necessary, define actions together with everybody. Okay, yeah, actually the best place is of course in the source, because yeah, the application that is master of the data, which is the ERP system, yeah, is actually responsible for the quality, and then it's used for different purposes, and planning can be one purpose, but there will be also other ones. Of course, sometimes you need to be flexible, and as a temporary solution, it can be done, of course, but it should always be linked to cleaning in the source, in my opinion. Actually, in most cases, we do extractions on daily basis, and uploads, that is another frequency, or often it's weekly or monthly, depending on the context. But for extractions, in most cases, we do it on a daily basis. And then there are two scenarios: a scheduled approach, where we do it during the night, or a more ad hoc approach that is often used when we do uploads. And for example, then the demand planner or the production planner says, okay, my plan is now complete. This can flow through SAP. And then, for example, in the planning tool, like Archiva, a button is foreseen for the planner to say, okay, I launch now my upload. And then at that moment, the data pipeline is triggered. Yes, that's a good question. And so here on the schema, you see, for example, in the demand planning, for a lot of customers, that's the starting point to get grip on what is the demand that comes, that will we have, and then later, okay, focus on the supply side. As I said, the different modules have different data requirements. For example, demand planning will need sales history, master data of materials, but there is no need for bonds, for example, bill of materials, or information about routings or the distribution flow. So that's the strength of the Datamacht. We can start with a small scope and then extend it in a later phase, but we can reuse what's already there. So that's the idea, that there is a central repository that can be used by different modules and that can be extended. And also on the other side, for example, frequent scenario is customers that migrate from SAP ECC to SAP S/4HANA. So there, the Datamacht can also be an abstraction layer there to make sure that there's less impact on the planning layer if such changes occur. Indeed, so that is linked to the layered approach here. So in the ingest area, we can capture data from multiple systems, and in the data store, we can then bring all that data together. Of course, there is still a need to link the information together. For example, a product in different systems, it can have different identifiers. There needs to be some way to link them together. That can be a master data management solution, that can be a reference key, a mapping table. So in some way, we need to make sure that we know how we can link the different systems together. And that's important during the design phase to define that and to identify that.
So thank you very much, everyone, for joining. Thank you, Tom, for the excellent explanation. We hope to see you guys soon in another webinar. And if you have any questions, you know where to find us. All right. Have a nice day, everyone. Thank you, Tom, for joining, and see you next time.
You're welcome.